This is Algebra 2 with Trig, 5C.1. We are solving radical equations. So when we solve an equation with radicals, as we see below, we need to isolate the radical on one side of the equation. You need to get the radical by itself. If you look at these first two examples, the radical is isolated. It's all by itself, so that's why it's if necessary. Then we're going to raise each side of the equation to the same power. So if you're working with the square root, you're going to raise it, you're going to square it to get rid of the square root. If you're working with a cubed root, you're going to cube it to get rid of a cubed root. Where it starts to get interesting is when we're down here and we're working with 4/3, 2/3. Gets interesting. So then you're going to solve what's ever left over. It's going to give you a polynomial and you solve it as we have in the past. Sometimes by factoring, often just by getting x by itself. So let's take a look at our first example. This is a cubed root. The index is 3. So to get rid of the cubed root, we're going to raise it to the third power. So when you cube a cubed root, you get what's inside. Now you have to pay attention to how we're going to get the x by itself. You first need to move the 5. You cannot subtract the 5 and the 11. They're unlike terms. But the 5 and the 27. The 5 is a positive number, so we're going to subtract the 5 over. That gives us negative 11x equals 22. And by dividing, we'll get negative 2. You can check your answer for extraneous solutions by plugging that negative 2 back in. Often negative numbers concern us, but when we plug our negative in here, we get negative 11 times negative 2, which is a positive 22. Adding the 5 gives us 27. Cube root of 27 is 3. So it worked out great. Where it really starts to cause trouble is when there are x's on both sides. Then you have to be extra cautious. So I wouldn't expect this one to have an extraneous, like I don't expect this one to have an extraneous, because we don't have x's on both sides. So we're going to square, because we're working with the square root. And when you square root, you get what's inside. Then you subtract the 6. A common mistake that people have made in the past is 3 squared, and they put down the number 6. They think about it as 3 times 2, not 3 times 3. You got to be sure to get a 9 there. We need to isolate the radical. You need the radical by itself. The 1 is not inside the radical. You've got to draw your radicals accurately so it's covering the correct amount. So we have to move that first. And sometimes we think that a radical can't equal a negative number. But that's a square root, or an even index cannot equal a negative. But an odd can equal a negative. So I'm going to raise this to the third power. And I have to use parentheses this time on this side because I want the negative to be affected also, even though it doesn't really change the result. We're cubing, so you get what's inside, and this gives you negative 8. So if x was negative 3, you plug negative 3 in here. Negative 3 minus 5 gives you negative 8. The cubed root of negative 8 is negative 2. Add 1 to negative 2, and you do get negative 1. So it works. We don't have x's on both sides of the equal sign, so we wouldn't expect there to be an extraneous. So you go ahead and try this one. Pause the video, work through this one, come on back, and we'll work you through it. So we see the radical is isolated already. So it's a cubed root, so we're going to raise it to the third power. You get the value that's inside. 2 times 2 times 2 is 8. Don't put a 6 there. 6x equals 18. Divide by 6 would give you 3. You can plug the 3 back into the problem. 6 times 3, that gives us 18. Minus 10 gives you 8. The cubed root of 8 is 2, and that matches. We don't have x's on both sides of the equal sign, so I would not expect an extraneous solution. But now we do. We have x's on both sides of the equal sign. This is where the extraneous really comes into play. Think about what you would do here. How is this problem different?
Still square them.
Because you have a square root, we're going to have to square both sides. Now the common mistake is distributing that through. This is not going to be x squared plus 4. You have to write x minus 2, and you have to write it twice. And you square a square root, you get the value that's inside. So this we have to FOIL. So that means x times x, you do get x squared. Then you get a negative 2x, then another negative 2x, which gives us a total of negative 4x. And then the negative 2 times negative 2 gives you the positive 4. So by distributing this in, you do get the x squared. You do get the positive 4, but you don't see the negative 4x. You need to be sure to get that value also. Now we subtract the x across, we subtract the 10 across. X squared minus 5x minus 6. These cross out completely. Now, this is always a tough one to factor. People make a common silly mistake in this situation. They're thinking about what numbers multiply to be 6 and add to be 5, and people think of 2 and 3, people think of 6 and 1. But with the 2 and the 3, both of the signs would have to be the same to add to be negative 5. Negative 2 and negative 3 would add to be negative 5, but they multiply to be a positive 6. So it can't be 2 and 3. It has to be 6 and 1. Because you have more negatives, we're going to say it's a negative 6 with a positive 1. X squared, positive 1, minus 6 gives us negative 5x, and different signs gives us a negative 6. Then we would do our zero product property, which would give us 6 and would give us negative 1. Now we got to check our answers. So we bring our answers up, and by plugging in 6, 6 minus 2 is 4. Plug the 6 in with the 10, that gives us 16. Square root of 16 is 4, so that one worked. You get a circle there. The negative 1 you plug in. Negative 1 minus 2 gives us a negative 3 on this side. Plug the negative 1 into your radical, and you get 10 minus 1 is 9. Square root of 9 is 3. It's not negative 3. It's not a plus or minus thing. So that did not work. So we put an X through that. We call it extraneous solution. Now pause the video and try to work through this example. We're going to square both sides because this is a square root. X plus 2 and x plus 2. Square, square root, you get what's inside. You FOIL this together. X squared plus 4x plus 4. Leaves us with an 2x plus 7. Minus that 2x across. Minus the 7 across. Makes 0 on one side. Then we factor it. X and x. We've got to multiply to be -3. We have to add to be 2. So the only way to multiply to be 3 is 3 and 1. The larger number has to be positive, so the 3 is positive. And then you can do the zero product property. We have a little bit more room to show that here. So you set them both to equal to 0, and you're going to get opposite signs. Notice what the negative's going to do. Most of the negatives will be your extraneous. Not 100%, but most of them. The negative in this case is going to be -3 plus 2 is going to leave us with a negative number on this side. If this was -3, like plus 6, then you would have a positive value on this side, and that's okay. So that's why it's still possible you could have a negative answer be accurate. So -3 plus 2 gives you a negative answer. A square root cannot equal a negative. So that is extraneous. Solution. Plugging in 1 gives you 3. Plugging in 1 gives you the square root of 9, which is 3. So that works. Let's take a look at what we have down here. How is this going to be different?
We're dealing with those exponents.
We have some funny exponents here. So you need to isolate this first. So we're going to add the 21 across. And that's going to give us, then 53 is negative. So we know our answer is going to be negative. So then we're going to have 32. We've got to get rid of the 2 first. That isolates our x. So we have to divide by 2 across. So we get x to the 4/3 equals positive 16. Now there's a couple different ways we can do this. We can treat this, which is not a problem here. Oh, actually it will be a problem here. We can treat this as x to the 4/3 equals 16. You can, which is very common, is to do the 4/3 all at once. You want to do the reciprocal because 12 over 12 is a value of 1. These are going to cross each other out and give you x to the first power. But we're also going to do that to this side. But what you need to watch out for this side is that now you're doing the 4th root to both sides. And when you do the 4th root to both sides, you need plus or minus. So you got to be sure to stick your plus or minus in here accurately. One way to help you see it and think about it is what would get rid of the 3 if you raise it to the 3rd power. Oh, I don't really want to do that to 16, but we can. Raise it to the 3rd power. This is not a great one without a calculator. 16 to the 3rd power. gives you 4,096. And now, how would we get rid of the fourth power? The 1/4 or fourth root, right. 1/4 or even the fourth root, might like that one actually better. But if you do that even denominator, you have to have plus or minus. So to do the fourth root, hit the math button, down to number 5, and that will put that 4 as your index. And that's going to be plus or minus 8. You might just like it with the fourth root symbol. It's still going to be plus or minus 8. So we'll try this side. Well, we're going to minus the 2 across. So you get x minus 1 to the 2/3 equals 4. Now you can do the reciprocal all at once. I would almost suggest to break it down into 2 steps. First, do the denominator, and that crosses the denominator out, and you're left with x minus 1 squared. That gives you 64. That doesn't require any pluses or minuses. Then you can do the square root, which gives you x minus 1, and when you take the square root of both sides of an equal sign, this is where plus or minus comes from. So you have to have x minus 1 equals 8, and x minus 1 equals negative 8. So when you add the 1 across, we get x equals 9, and when you add the 1 across, x equals negative 7. Look at what the plus or minus was. This is where people make a mistake. They sometimes, or you sometimes, say x plus 1 and x minus 1. You don't change the plus inside the binomial. When you take the square root of 64, this is where the plus or minus comes from. You're always adding 1 in this case. What are we going to do first here? You got to divide by 2 first. So x to the 3/4 equals 8. Then we could raise both to the power of 4. That gives us x cubed. That is making our numbers get really big. But it helps us understand where this plus or minus number comes from. So again, 8 to the 4th power, we come up with that 4,096 again. Then when we take the cubed root of both sides, do we have to worry about plus or minus? Not at all. So hitting the math button, and we scroll down to the cube root of 4,096. What times what times what makes that? Would be 16. That is not a plus or minus answer because we're not taking an even root of both sides of the equal sign. Here's a crazy word problem. Power consumption, the amount of power used in an appliance is given by this equation, where I is the current in amps, R is the resistance in ohms, and P is the power in watts. If the appliance uses the current of 12 amps and the resistance of 25 ohms, then what is the power? So our I is 12. The square root of P, we don't know the P, and the R was 25. What are we going to do here? Kind of do two different things. You can't reduce here, so you could think about it as 12 the square root of P over the square root of 25. Some people might just square both sides, and that would work. But then I have to square 12 and get 144, and that's making numbers pretty big. I know, I recognize this is a perfect square. So by taking the square root there, I'm just trying to keep my numbers a little bit smaller, and I got 5. So then I'm going to multiply 5 to both sides, and that gives me 60. Now how are we going to get the P by itself? We still have to square it. Square both sides. Well, what is 6 times 6? That's 36. And then you're going to have 2 zeros. So that can really help. So it's 3,600 watts. There's a couple different ways you could have set this up and you would still get to 3,600. So we come down to our next one. You go ahead and work this one out, and you're trying to find the R value. So remember, our equation is I equals the square root of P over R. That's our formula. So we're trying to find R. If the current is 10 amps, we don't know R, but P is 2,000. Now in this case, I'm going to square both sides. That's always an option. You got 100. You've got 2,000 over R. Multiply by R to both sides. That gives you 100 R equals 2,000. And then we can divide by the 100. You don't even need a calculator because the zeros cross off. And we get 20. R is ohms. So OHMS. So 2 last problems. You work through these, pause the video, work through these, and then I will solve them for you. This has x's on both sides, but regardless of that, we do have to square both sides. You get x plus 5, and you have to have that twice. You cannot distribute in. Check your work to see what you did. When you FOIL this together, you're going to get x squared. 5x and 5x gives you 10x. 5 and 5 gives you 25. So we get x squared plus 9x plus 14. Looks like 7 and 2 makes 9. Positive 2, positive 7. Oh, here's an interesting one. We're going to get 2 negative answers. So does that mean that we have no solutions? I bet that one of them will still work. When you plug in -2, you get -2 plus 5. That gives us a positive 3. So that negative is still going to work. -2 gives us 9. The square root of 9 is 3. So that one worked. So it is possible to have a negative answer. -7, though, plus 5 still gives us a negative answer that our square root is going to equal. That's never going to happen. So I don't have to test any further. Extraneous solution. And then very similarly here, if you get carried away, you're going to make an answer that is extraneous because you're going to square the -2 to get a positive 4. But you know a square root cannot equal a negative number. So this is no real solution. You don't need to go any farther. A square root cannot equal a negative number. If you go ahead and try to solve this anyway, you'll come up with an answer. X minus 4 equals -2. You'll square that. You'll get x minus 4 equals 4. You'll get 8. And when you plug in 8, square root of 4 is 2. Plus 8 gives you 10. Doesn't give you 6. Good job.